Okay, so this video is going to cover how to go through steps, uh, basically steps 10, 11, 12, 13 on this activity 3.2.4. So hopefully step 10 or step 9, you opened up your manufacturing data tab. The big thing you've got to do here is to make a copy of it because you don't have edit access to this one. So you make a copy and that'll give you access to be able to actually do the editing on it. Now at this point then, you're going to want to okay. At this point then, you've got access to the original, the data from the original equipment making these papers. You can see the different lot numbers here. There's 50 samples, and you can see the IV, or what was that called? IV stood for intrinsic viscosity. And so it created a little table there of all your values. You found your mean, you found your standard deviation, created a probability table, and then a histogram. So what you're going to be doing here is creating that same exact stuff with the second set of data. Get that. There we go. So you're going to use this test data here to do the exact same things that they had done on the front. So you're going to first of all calculate the sample mean and standard deviation of these. So we'll just go ahead and make a spot over here. Sample mean and sample standard deviation. So calculating any of these things in a spreadsheet is just a matter of typing equals and then spelling out what you want to do. So mean is average. And so we got right there, second one down is average. And all I have to do is just highlight my data, all 50 entries. I don't want the actual number of the entries, just the entries themselves, and hit enter. You see there's my average right there. If I want the sample standard deviation, I just hit the same thing, equals ST, and right there, sample standard deviation is STDEV.S. The population would be P. If you read the directions there, it talked about the difference between those. We want the sample standard deviation because this is a sample. It's not all the roles, it's just a sample of 50, and hit enter. And so there we've got our sample standard deviation 1.08 and our mean 22.82. You can see how it compares here. It does have a slightly lower mean and a much smaller standard deviation, which is something we'll want to think about here in a second. Now, the next thing we're going to do is to construct a frequency histogram. So for this one, what we can do, we don't need to construct a frequency table in Google. We can directly go to a frequency histogram. We just highlight our data, go insert chart. Maybe, there we go, insert chart. And we want to make sure we pick the right type. So instead of a column chart, we want a histogram. And then we can go ahead and select our ranges here. It might be a good idea to kind of match what they do on the other one. But our horizontal axis, we can set a minimum and maximum value. So minimum of 20, the maximum value you see in here, go away. The maximum value I think you see in here is 24, if I'm not mistaken. 20. Oh, there's a 20. There's a 26. So it looks like 26 is the highest. So maybe we want to set our maximum value at 26, and you get a little bit better view of the data there. That's kind of going on. Other things that you can do if you want to make these a little bit more, more like the other one, is to set your bucket size. So we've got from 20 to 26, so we could set it to 1, which would just be 20 to 21, 21 to 22, 23 to 24. We could also set it to halves and things like that. If you look at your original here, They've got it just set to individuals. How many of each of them are there? Technically, that's not a histogram. This is a histogram, but you can kind of see how that might work there. And so we've got our histogram. Basically, what that's showing us is how common each of the, can I move this? How common each of the different numbers are. There we go. I should be able to move this. There. So it shows us how common each of the different numbers are. So from 20 to 21, there is one entry. And if you were to search through here, you'd find there's one right there. From 21 to 22, there are two entries. And so you can see there's a 21, and then there's a 21. And then you've got 20 to 23 is 17, 19 from 23 to 24, 8 from 24 to 25, and 2 from 25 to 26. There must be two 26s in there somewhere. I didn't see two of them, but they must be in there. Okay, and so that's pretty much what you're going to be doing for that part. Then it wants you to compare the results of the two histograms. So here you've got yours, and then you've got the other one. You can see they both kind of have a very similar shape. They're more or less symmetrical. But one thing you're going to notice here is this one goes from 19 all the way up to 27, where this one goes from 20 up to 26. So it's much closer together, and that's supported by this standard deviation number here being a lot smaller. Here the standard deviation is 1.76, and here the number is 1.08. That means your data is closer together. It's more consistent, which is a good thing. And you'll see your sample mean here has not changed a whole lot. It went from 23 to 22.8, which is about, it's not a whole lot different. And if you're looking at the requirements of what they wanted, they needed a range between 21 and 25. So hitting about 23 is right where you want to be. So either one of those are fine, but this is where it's important. Now we can take a look at this and say how much of this is between 21 and 25. Well, we've got all those. The only ones outside are those two and that one. So in that case, it's a lot better than the other one, where there were a lot more of them outside that range. So if you looked here, we had 3, 1 there, 3 there, and 1 there. So we got from about 8 outside that range to about, what was that, 1, 2, 3, 4, 5 outside that range. So a little bit better. That's up to you. In one of the conclusion questions, they're going to ask you, is the investment in a new machine actually worth it to make that improvement? So go ahead and answer the rest of those questions, and then we should be done.